Okay, how much nickel 56 do we need to produce the light curve? We know if we plot the luminosity against time, we get the initial peak and then a slow decline, and this comes out as a peak of about 2 by 10 to the 36 watts, and that lasts about 2 weeks. This is caused by the nickel turning into cobalt, which generates 1.7 mega electron volts for every atom, whereas actually the bulk of the power is down here, which is going from cobalt to iron. But let's just look at the peak here for the purposes of this calculation. So the first thing to work out is the total energy liberated by the nickel to cobalt. So that energy is going to be equal to the luminosity, 2 by 10 to the 36 watts. So watt is a joule per second. So we need to multiply that by the number of seconds to turn it into actual energy from power. So we've got 2 weeks times 7 days in a week times 24 hours in a day times 60 minutes in an hour times 60 seconds in a minute, which comes out at about 2.4 by 10 to the 42 joules. Okay, so that's the amount of energy we're seeing liberated by the nickel going to cobalt. How many atoms of nickel 56 do you need to do that? Well, each atom will liberate, that's 1.7 mega electron volts, so the energy per atom equals 1.7 by 10 to the 6, 10 to the 6 is a mega electron volts, times the electron volt, which is 1.6 by 10 to the minus 19 joules. So that comes out as 2.7 by 10 to the 13 to the minus 13 joules. So how many atoms do we need? We can divide this by that, and that will tell us the number of atoms. Which is about 9 by 10 to the 54 atoms. But each atom weighs around 56 times the atomic mass unit. So you multiply this by that, you end up with about 10 to the 30 kilograms as your total mass. Mass of nickel 56, which is about half a solar mass.